All right, so we got one theorem, and what we're talking about, and we looked at it a little bit at the end yesterday, of how can we tell if two figures are in fact similar? All right, and we looked at that one that had, you know, it was a hexagon or whatever yesterday, and all the sides were proportional, but only one pair of angles was congruent. And everybody thought that it was similar, but because the angles weren't the same, it wasn't similar. So we're going to key in on triangles here because triangles are the easiest polygon to work with because there's only 3 sides. So we're going to concentrate just on triangles over the next couple days and talk about how can we prove that triangles are similar. And I know I use the word prove, but we don't see proofs in it. Okay, there might be some explanations, right, of which theorem says that these are similar, but we don't have an actual 2-column proof. Okay. So here's one of our reasons. This is the one reason we're talking about today. The one reason we can say that 2 triangles are similar. And this is angle-angle similarity. Angle-angle similarity here. So this says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. That's all we need. Now, we only say 2 angles, but if we know 2 angles are congruent, what about the third angle? We know that's congruent as well, right? Third angle's here. So really, we're saying if all the angles in one are equal to all the angles in the other, we don't need to know anything about the sides. We know that those two triangles are going to be similar. Okay, the sides will be proportional. If the angles are all congruent, the sides will be proportional, no matter what, in a triangle. Now, this only works for a triangle. Okay, you can't get this in a quadrilateral, because if you think about it, right, those 2 figures have all the same angles, and they're not similar. One's a square, one's a rectangle. So we cannot use this for any other shape other than a triangle. But in that triangle, in those triangles, if you have 2 pairs of congruent angles, that's enough to say they are similar. And once we know they're similar, then we can apply that, and we can set up proportions, we can solve for x, we can do all that stuff. Okay? But first, we have to say that they are similar based on this angle-angle similarity. Our abbreviation for angle-angle similarity, you see AA there. I'm going to say AA with the similar sign on it, just so that we know for sure this is using it to say that these are similar. So this is angle-angle similarity, AA with the similar sign. Angle-angle similarity. We're going to see some different things today. There's not a whole lot in this section. You know, this is the only theorem that we have, so everything that we're doing today is based off of this. But a couple things that we are looking at, we're not going to look at that proof. Like I said, no proof here. But a bunch of the questions are going to be, here's a situation, is this enough to say that they are similar? So we got to see, do we have at least 2 pairs of congruent angles? Let's look at that. Do we have enough information here?
Yes.
I heard yes, I heard no.
Oh, yes.
Why yes?
Because 26 plus 64 is 90, then you have 90-degree angle, so it equals 180.
Yeah, so if we do triangle sum theorem, right? Triangle sum theorem, I got 90, I got 64. This one would have to be 26. Right? Now I've got 2 pairs of congruent sides. I could do the same thing over here, get 64. I don't need to. But I have 2 pairs of congruent angles. That's enough angle-angle similarity to say that the triangles are congruent, are similar. Okay? And then it asks us to write a similarity statement. Okay, remember, similarity statement is triangle this is similar to triangle that. I want you to go ahead and write a similarity statement for this. Make sure that the angles are matching. Right? Everything's got to be lined up in our similarity statement. And talk to somebody, see if theirs makes sense. Might not be the same as yours, see if theirs works. All right, here we go. Bridget, give me a similarity statement here. Tyler?
CDE is similar to KGH.
All right, so C and K match up, D and G match up, E and H match up. There you go. You could have this in different orders as long as those letters still match up, right? You could have it in any order, EDC, ECD, DEC, right? Doesn't matter as long as the second one matches. Good, so that's part of what they're gonna ask you. Any questions on that? Okay. Good, so that's the first thing. The next thing, well, this is still the same idea, right? Saying why we can say that they are similar. Why don't you go ahead and talk to somebody about it. What theorems, what postulates, whatever would you use to say that these are in fact similar? All right, so for this, the left one here, we already know we have one pair of congruent angles. What do we use to get another pair of congruent angles? Theorem, property, postulate. For which angles?
Angle AEB and ABC.
For AEB. And then what was the other one?
ABC.
ADC. There you go. Yeah, so these two we can do. So technically what we would be doing is we're saying that these two are congruent. So converse of corresponding would say that these two are parallel. And then corresponding would say that these two are congruent. Right? What else could we do instead of that? What's the other angle that we need? A. For both of them? For both triangles, right? What's it?
There's an A in both triangles in the same spot, so they gotta be equal.
Yeah. What property is that? Reflexive property, right? Same, one angle is congruent to itself. Right? This angle A is the same for both, so that's reflexive property. A is congruent to A. So that would be enough right there. Okay. Good, so then we could use AA similarity. How about here? What could we say here, Tyler?
It is AIA twice.
We could use AIA, right? Because we got parallel lines, we're looking at those Z shapes. So Tyler, which angles are congruent?
S and U and R.
S and U, R and T.
And you can also say that SVR and VT are congruent to
Good, yeah, vertical angles can get us there too, right, for those middle ones. So AIA and vertical angles, some combination of those allows us to get angle similarity. Okay, good. Be on the lookout for those parallel lines. Anytime you see parallel lines, you gotta be thinking AIA. You can also be thinking corresponding. Like here, if we knew that these were parallel, or once we know they're parallel, then corresponding. And it's typically gonna be one of those two that you're gonna see. Okay, so that's a good look at what you're gonna see there. In the homework, you're gonna see this figure, you're gonna see it a few times, because they're gonna ask for a bunch of different things. Right, but once we know that they are parallel, then we can use AIA, we can use that sort of stuff. Right, we just gotta know, kind of figure out some stuff about that first, and then we can start finding the corresponding sides and angles and all of that. Okay, so you will see that sort of thing. All right, any questions so far? All right. Other thing that we're gonna look at, we've seen this type of problem before with our word problem. I know 7th grade math, I don't know if you guys, well, you probably did last year. Or 2 years ago, maybe even, for 7th grade math. They would go outside and measure shadows and do something like that. Did you guys ever do that? No. Okay. 7th grade math here does. And it's this idea of indirect measurement.
Can we go back to stuff in three?
No.
This is easy.
Right, so we want to look at why this works, okay? The idea behind this is you're looking at height and shadow of two different things. So for example, the flagpole shadow is 50 feet. The woman's shadow is 40 inches. Her height is 5'4". Right, and we're looking for the height of the flagpole.
That's it, all flagpole.
Yeah.
It's about over 5 foot tall.
Either that or it's a very small building.
It says it's not drawn to scale.
There you go.
Yeah, but.
Anyway. So the idea behind this, when you're looking at a shadow, right, it's talking about the sun, and the sun is creating that shadow. So what's happening with the sun's rays to create that shadow is we are creating a triangle. Okay, you're creating a triangle with the person and the shadow. Same thing here, you're creating that triangle,
That'd be one thing.
and they're gonna be right triangles, okay? They're gonna be right triangles because the flagpole is standing straight up, assuming that the woman is standing straight up and not leaning. We have right angles, and because the sun's rays always come down, are gonna be at the same angle at the same time, then we know that these angles are congruent. Right, so right there, what we know is angle similarity. And that's why this sort of thing works. In the past, when we taught this, when we looked at this, we never really got into why can we do it. We just said, hey, this is what you do. But the reason why this works is because you've got that angle similarity. Okay, so now we've got two similar triangles here. We've got enough information to set up a proportion and solve. Okay, I want you to go ahead, set up a proportion and solve for x, solve for the height here. Careful of your labels.
Wait, we just need the triangle to prove that we can solve for it?
Yeah, we're just solving for x, right? So I drew in those triangles to show why we can solve or how we can solve for x.
Oh.
obviously we have different labels here, right? We have different units. So we gotta do something about that.
I don't know, you know. So I guess you'll move that.
It depends on what type of building, but between 10 and 12 feet.
Depends what color your ceiling is.
Then yeah, that's building. Scale.
No, but like, but if it was drawn to scale.
If I grab a ruler right now, that's not 70 feet.
I can't.
So it's not drawn
That's
to
not what they're
scale.
saying. The scale would be like, if you, yeah, anyway.
Yeah, it would be like 120
Here's my question.
feet tall.
Why does
I don't-
lady look like she's like 11 foot tall, if she's taller than at least 1 story?
Right. That's what's not drawn to scale.
It's the
Maybe
perspective.
building
Perspective, right.
is in the background.
Yeah.
Yeah.
You gotta.
Look at that
Oh,
art
shoot.
knowledge coming out.
Oh, I jumped on.
Or
I
maybe
did, I
it
did
just
too
says
now.
it's not drawn to scale.
Wait, you can do
I mean, Jim's.
Anyway, hey, talk to somebody, see what they set up, see what they got for an answer. 'Cause I think we got some different things going on.
Say.
It is 640.
Wait,
How many?
I see that 64 over 40 and up.
Why did I?
You can't leave it as.
Yeah, I said X. I set up 64 over.
Oh, you had this one that said. Yeah, cause it, cause you don't want to.
Yeah.
Yeah. Alright.
All right. Raise your hand, tell me what proportion did you set up? Okay, what'd you set up? Holden, what'd you set up?
I set up 600 over 40 is similar to X over 64.
Like that? Okay. And we'll do something different here. Times it by 64 over X, 60 over X. Okay. 60 would be 5 foot, right?
Oh.
5'4", yeah, so that would be 64. But that's good, that setup is good. Right, if we turn that into 64. Now,
I did 64 over 40 and then X over 600.
Haley?
I did 40 over 600 between 64 and 50. That's a lot of ways to do this.
It's all of them? What's,
I did 600 over 40 and, oh, never mind.
you did that one?
You have to simplify, I just feel like that's hard sometimes.
You don't have to.
What do you mean simplify?
Like it's down, like,
Once you get an answer,
no. Like the first part,
like this,
yeah.
you don't have to. No, it just, you're dealing with smaller numbers then, right? I mean, this right here is the same thing as this, right? And so all of these are gonna work, right? All of these are gonna work because if you look at all of them, when you cross multiply, you're gonna have the same thing. You cross multiply, you're gonna have 40 times X and then 64 times 600. So all of them represent the same thing, right? They set it up different ways. It still means the same thing. When we do that, we're gonna get X is equal to something. What is X equal to? 960.
Or 80 feet.
And that's inches, but they're not asking about inches. They're saying how tall is its nearest foot? So then we gotta convert back, right? What's that gonna be?
80 feet.
80 feet, okay? So we can do that, right? We can set up that proportion, we can solve for X, we're gonna have to convert it back into feet. Any questions on that right now? Before I point something out? Okay, we don't have to convert this 50 feet. Okay? We don't have to convert this 50 feet. We can leave it as 50. What needs to be true, and I know we always want the same units, right? But as long as you have the same units in each figure, those units can be different. So you could have all inches in one figure and all feet in the other, and that's completely okay. It's still gonna work. If I do that, I still have to change this into 64 inches. I can't get away from that. But if I set up my proportion now, right, and I'm gonna set up the proportion using corresponding sides, like a scale factor sort of thing. So if I go X over 64 and 50 over 40, this is completely okay. Go ahead, cross multiply that. 64 times 50 divided by 40.
It's gonna be 80 feet.
I'm gonna get 80 right away, right? But I don't have to worry about that converting. So if I look at this, right, what helps me to understand that I can do this is if you throw the labels in your proportion. This is 64 inches, this is 40 inches, this is 50 feet. And what am I looking for? I'm looking for a number of feet. So as long as you have two that are the same, we don't have to convert to create that proportion. Okay, now if this was inches, feet, and we wanted inches, then yeah, convert it. But if you have 2 and 2 of the same labels, we're okay there. And we don't have to do that convert and then convert back. Okay, that's something new that we haven't really talked about ever. So I wanted to point that out, how we don't have to convert right away. Now within the same figure, right? Yeah, let's convert. I wouldn't do this as inches and this is 5.25 feet. All right, I wouldn't do that because that's not it anyway, but 5.3 repeated feet. That wouldn't make sense. 412, 1/3, 0.3 repeated. Okay, any questions on that? How we can set that up and get that answer right away? All right, excellent. Any questions on anything today?
Probably not.
You might, yeah, you might see it on test too.
Oh, that's